The sine rule, as it says here, it applies to all triangles, but we don't tend to use it for right angle triangles because there's easier ways. There's Pythagoras and there's the ratios that we've used already. So we use this particularly when there's no right angle. It's used to find missing sides or angles. And here is the sine rule basically written down. Look at this picture here. This is a sort of convention that's used to set out the sine rule. We don't have to use the letters A, B, and C. It can be anything, X, Y, Z. But we tend to, if we call this angle A, then the sine rule assumes that you've called the side opposite that side A. So side A is always opposite angle A, side B is always opposite angle B, and so on. Side C opposite angle C. All the sine rule is telling us is that the ratio of one side, let's call it, say, side A, to the sine of the angle opposite that is always the same ratio. So the ratio of side A to sine A is the same as the ratio of side B to the sine of angle B. It's the same as the ratio of side C to the sine of angle C. The ratios are always the same. So if I know one of the ratios, and by that I mean if I know one side and the angle opposite it, then I can use the sine rule to find out the rest of the information about the triangle, so long as I've got one other piece of information. So that's what the sine rule says. Let's look at an example and see how we can use it. So in this particular example, I want us to find the missing sides and the angles. We can find the length of the missing side and the rest of the angles using the sine rule. So if you just make a note of this example, find the missing side. Well, actually there's only one missing side here, that's side C, and the angles. In other words, we can find out all about the triangle so long as we know one ratio and one other piece of information. Do we know one ratio? We know side B and the angle opposite it, so we know one ratio. If you don't know a ratio, you can't use the sine rule, so that's the first thing to look for. If you don't know a ratio, you have to either say I can't do it or use another rule, the cosine rule, which we'll come to. Okay, so we know one ratio and we know another piece of information. We know side A. So what can we find out about this triangle at the moment using the sine rule? I know one ratio and I know that side. So what can I find? I can find the angle opposite it, yes. So the plan is, the first thing to do is, what is it we can find out about this thing? We can find out this missing angle. If we know this side and one ratio, we can find the missing angle. Well, once I know that angle, I know this already, then that's obvious because all the angles of the triangle add up to 180. So I then know that angle, and once I know angle C, I can then find side C. So the plan is to first of all find angle A using the sine rule. Two, find angle C because all the angles in the triangle equal 180. 3, find side C using the sine rule. So that's what we're going to do. There's 3 steps to solving this problem. And I don't think it's a bad idea to write down your plan, like I was suggesting for the surface area and volume. What are you going to do? You want to be engineers, so the plan that you're going to carry out, good idea to write it down. So, 1, we're going to find angle A using the sine rule. So let's go through this plan then and execute it. Number 1. So we write down the ratio we know. We know side B and angle B. So side B, which is 3.8 over sine 60, equals the bit of information we know, which is 4.2, over the sine of A. So we can find this, hopefully. There's only one unknown, so in theory we can find out what it is. Yeah, 3.8 over sine 60 equals 4.2 over sine A. The thing that we're after is underneath. This ratio, let's go back to this note we made here, the sine rule, and that's how it's often written. A over sine A equals B over sine B. The ratios are the same. It's just as relevant the other way up. The ratio would still be true. So if I tip these upside down, the ratios would still be true. And if I'm after an angle, it's best to write the ratio that way up. So actually at this stage here, I would probably not write it like that, but I would write it as sine 60 over 3.8 equals sine A over 4.2. I'll flip it upside down because the thing I want to find is then at the top. So that's worth remembering. Now, I'm after sine A. It's divided by 4.2, so multiply by 4.2 to get rid of it. So sine 60 over 3.8 multiplied by 4.2 gives me the sine of the angle I'm after. Right, Josh? Let's see if you get it right, doing it that way. Yeah, I think so, yeah. Okay. Now we get to here. The sine of the angle that we're after is given by this. We want the angle A. So actually, angle A is the inverse sine of all this left-hand side. It's the inverse sine of this, sine 60 over 3.8 times 4.2. And that is what I put into my calculator. So to the nearest degree, to two significant figures, 73 degrees. So for 2, angle C equals 180 degrees minus 73 degrees plus 60 degrees, which turns out to be 47 degrees. So we've got angle A and we've got angle C. And then we've got one last thing to do, and that's find side C. Now we know the angle, we can say C, side C over the sine of 47, which is angle C, equals the ratio we know, which was B over sine B. So again, 3.8 over sine 60. So we use the sine rule again. The side we want to find over the sine of the angle opposite it, 47 degrees equals 3.8 over sine 60, the ratio we knew in the first place. So now again, I'll just multiply both sides by sine 47 to get rid of that. So C equals 3.8 over sine 60 times sine 47. And then put that into a calculator and I get C. Gives us 3.2. So in this problem we've got to find, and this is exercise 98 page 224, one of the questions in there, and I'm going to ask you to have a look at some of the others in a second, but we've got to find all the missing sides. So there's two missing sides, A and C, and the missing angle. There's an error in the textbook, it should be 14.1 in the side A, and it also asks you to find the area, but we're not going to bother about finding the area at this stage. So what's the plan to find this, please? What can we find out? Just tell me first and then we'll do it. Find angle C. Right. Yep. Good. So we can do that easily enough. Once we've got angle C, then what do we do? Yep. To use the sine rule for A and C, and then C. Okay. 5 minutes to do that. Okay. Let's look at this then. So we found angle C, that's 83 degrees in this example. Right, the sine rule to find A and C. It doesn't matter which order we do it in because we know all the angles. So let's find side A first. What I say is the ratio of side A, which is what I want to find, to the sine of the angle opposite it, equals the ratio of the side I know divided by the sine of the angle opposite to that, Josh. Right? So what I write is A over the sine of, what's the angle opposite A? 29 degrees. Equals the side I know, which is 27 millimeters, divided by the sine of the angle opposite that, which is 68. That's what the sine rule tells me to do. And then, and this is the algebra bit I was talking about with Sonny. Focus in, please. I've got to get A. A is divided by the sine of 29. So, and this is the algebra step, multiply by the sine of 29 to get rid of it. A equals, what's on the right-hand side already, multiplied by the sine of 29. And then I get my calculator and work that out. And what did it come to? Millimeters, yeah. Or 14 to two significant figures if we're going to go to the same accuracy as in the question. And then we do the similar thing for side C. I say C over the sine of 83 degrees, which is the missing angle we just found, equals, same again, 27 over sine 68. And again, multiply both sides by the sine of 83, and I get C equals 27 over the sine of 68 times the sine of 83, and that is 28.9 millimeters, or 29 if you wanted to go to two significant figures.